Wait a second. Wait, John, you're not doing something. You're not just going to the third shit. You're going to miss your Rocky shirt. Yeah, they're getting kind of lost. Wait, really? Wait. I really
Glad it's like 22 when I
Alright guys, let's look. So we're going to start with rectangular coordinates, which is what you guys know. Rectangular just means the XY plane, that's what you're used to. So if I went over a certain distance on the x-axis and up a certain distance on the y-axis, I have a point here. That would be the point XY, right? Hopefully you guys know that.
Now I know the terminology.
Okay. Yeah, no, I don't know. Do you guys know that that's called rectangular, or is that?
Now we know.
Okay, well that is the rectangular coordinate. And I'm going to do polar coordinates. So, when we're like polar bears, yes, no. When we're doing polar, you have a radius now, and you have an angle that you're looking at. So you still have ordered pairs, but it's no longer an XY ordered pair. It's an R and a theta. Okay, so the R is the length, and the theta is the angle. All right, so if I was plotting a point, let's say right here. Okay, the ordered pair for that would be R theta. What I'm looking at, the R is that distance from, it's no longer called the origin, it's called the pole. Okay, the pole in polar is like the origin in rectangular. And then the angle you're looking at, if we start here, it's this angle right in there, that theta. Okay, so that point is R theta. And we're going to plot a lot of points, and there's different ways to name them. It'll make sense. It's not too bad. Okay? All right. So let's look down here. So on your polar grid here, you don't have every angle marked. This is essentially like 0 radians. This one is pi over 6. This one is pi over 3. This is pi over 2. Just so you guys can see them. 2 pi over 3. You could keep going all the way around. What has been skipped? Pi over 4. Where would that go? Okay, just making sure you guys know where that is. All right. So again, this corresponds very nicely to your unit circle. All right, so we are going to plot the point 6 pi over 4. When it is a positive radius, that means you're starting from your pole and you are counting out 6 to the right. If it was a negative 6, where do you think you'd go? Yep, you'd start from the pole and you'd go left. Okay, so always do the radius first and then move whatever angle it's telling you. So I count out 6 and then I'm going to travel through an angle of pi over 4. So I'm going to put my point like right there. Okay. Just like with your unit circle, you can also have negative angles. Okay, so there's a lot of different ways you could name this exact same point. If I want to stick with going positive 6 first, so I come out here a positive 6. Could I go backwards and end up there? Yeah, what angle would I have to travel through to get back there? Yes, negative 7 pi over 4. That's going to take you to the exact same spot. Okay. You with me on that? Okay. What if I start with a negative radius? If I start at negative 6, so if I'm over here, how can I get there? Like, what am I traveling? What angle am I traveling through? What'd you say? I think you were right. I just didn't. 5 pi over 4. Yeah, because if you start here, this would now be pi over 4, 3 pi over 4, 5 pi over 4. Does that make sense, guys? It's like you're starting with a new initial spot. So we could have negative 6, 5 pi over 4. We could do another -6.
Negative 3 pi over 4, does that make sense? Because it starts -6 and then go backwards 3 pi over 4.
Okay. If you wanted, you could even go around more than one time. So let's go back to it being a +6. What if I went all the way around and then to the pi over 4 again? What would that be? Yep. Kind of like coterminal angles, okay? Just different ways to get there. Questions on any of these? How those are working? Okay with the negatives? Okay. So you can think about a formula for this if you want. I honestly just count my way forward or backwards around the circle. The actual formula, if you stick with a positive r, then you have theta plus or minus 2 pi k. Or if you have negative r, you start with your theta, you subtract pi, and then you do plus or minus 2 pi k, which to me, that's all much more complicated than just looking at your graph and counting. But if you really like formulas, there you go. Okay, so the next little section here, I want you guys to try A, B, C, and D. You are going to plot the point first, and then come up with 2 other ways that you could name it. I'd like you to do one positive R and one negative R with your other ways of naming it. If it starts as a negative, though, you can just do 2 positive R's, that's fine. Lots of options there. So I'll give you a few minutes here to plot and name them.
I see some of you doing it, but when you finish, go ahead and compare with someone around you.
Guys, you can check your points up here. A and B are really close together, but I've labeled A, B, C, and D, so you can check your graph. Your own and then, guys, I'm going to write 2 possibilities that you could have for points here. There are plenty of other options, though.
Because you use your brain.
I prefer that you just think, but that's
I was trying to say visualization, but that doesn't.
You have to use someone else's brain.
Can I buy
You see it?
But, like, let's say, you just download the information to your brain. Download all of what's
another one here, you could have done 6, maybe 3, we could have done another. Lots of options up here for you. If you are not sure, if you wrote something else, not sure if it's right or not, let me know. How are we doing with these? Good? So far, so good? We're starting with basics, guys. It's like when you started with rectangular and you had to plot a point. Eventually, you guys will get into some graphs that are actually very, very interesting. You have a polar mode on your calculator. You'll see some graphs that have petals.
Yeah,
I was using like petals, like
petals on a flower.
yeah, he said yes at first. What? That is interesting.
Guys, on your calculator, though, I see a couple of you with it out. If you do change your mode to polar, your x key, you know, that's the variable, it's no longer going to be an x. It's going to be a theta. And when you go to y equals, it's not going to say y equals, it's going to say r equals, okay? So it's different. Yeah. I wasn't lying. Jonathan's shocked, I don't know.
Hold on, next, just read it.
Alright, so first step, I gotta figure out where it is.
Do you want like a minute to just play with your calculator and look at it?
Yes. So cool.
It is cool, yes.
What is your calculator? Is that gonna be the house? Yeah, I was getting a calculator. Why don't you yeah, you can go my calculator. So I'm gonna look this up really yeah, now let's do the
been using the wrong thing all my life.
I've been writing down the French. It was so weird. Wait, what? Oh, you could. You're talking to
You finally realize how you got it.
So guys, you can mess around with, like eventually we'll get to where we're graphing things like this. You know, and you can see, kind of looks like a gingerbread man, doesn't it? Doesn't it look like that? Yeah, that's just, I just
Looks
made
like you
that
got
up.
split in half by Molly.
Wow, thanks for taking
Yes,
that.
I would be in radians, but you can change.
Oh, I'm gonna forget to do that. Oh, I'm gonna have to go.
They have Bangladesh. No.
I'm all about all the different languages on the calculator. Really?
I don't think they have
So it's drawing different petals for you.
It's a butterfly.
Wait, can you go over the
I'm gonna go over.
Hey, look, I drew a little circle.
Gotta have the
There, that looks
I drew a
better.
lopsided circle. Flower.
Yeah. So, like, this is what, you know, we have to start baby steps. Plot a point first, okay? But eventually, this is the stuff you guys will be graphing.
Look, I drew a
And
big
you'll know how to graph this by hand, okay? And you'll graph, like I have it graphing from the interval 0 to 2 pi. You may graph only over a specific interval and like get a part of the graph. Like if I change my, like let's say I go from pi over 2
Mine doesn't look like a butterfly.
to pi.
What do you mean she can't see?
Oh, wait.
See how it like eliminates parts of your graph? See down here? So the window over which you graph, or your theta values, will change things drastically. Like your theta, min and max. If I go back to 0 to 2 pi,
Window is 360.
you will get all of your petals back.
Wow, that totally looks like my graph. Imagine if you
Okay?
no way this afternoon.
I know, it's interesting. As you watch it graph, you know, it doesn't graph like this. It doesn't go here, and here, and here, and here. Do you see how it's like here, and then down here, and then up here, and then over here? Like, you're going to have to understand how to graph in these orders. So, again, not today, but you will get there. Well, you have a different equation than I do, I'm sure.
Yeah.
I actually went zoom and trig because it makes it fit nicely.
So, I think I messed up my calculator.
No, you didn't.
I have no idea what I'm doing. Actually, not. Why did I follow you? Alright, we'll see how this is graphic. The reset button doesn't reset. Well, that's why I coded it for college now. Now I've already seen a power code. Like we were doing that.
Oh yeah, well, come on, find something. You got
It's like flower made out of something. I broke my calculator, but I think I have a different problem.
I feel like I want to buy like, you know, a calculator like this.
Like I
What do I do? You're the one who pulled it. What I did was I landed my I was contemplating doing this, but then I saw like families and everything just like talking to me now. That was a really awkward.
I don't think there's actually anything in there on this one. I think it's just
So like I
What is this mode? What is Dude, why did you do this? Because you know what I learned today? This is what I learned today. That's what I got wrong. That's the reason they gave them. No, I think you I got the riddle and I saw the riddle. I'm like, yeah, this is not exciting. I love that.
Okay, guys, so you can clearly get some very interesting looking graphs, right? Yeah, need help?
You learn about commas? Everyone's just looking around. That's my turn.
Change that number in front of the theta. You made it bigger. All right, guys. Go ahead and turn the page in your packet. Let's get back to our notes. We need to do a little converting now.
Oh no.
Okay, guys, put your calculators away. Friday, you can play with your calculators, okay? You can draw pictures on your calculator. There's actually really interesting stuff on Desmos where you can like draw the
Wait a second. No, Alex. Calm down. No weekends. No weekends. Year-round.
Okay, guys, look up here. Back to your notes. We're going back to points. Remember, we gotta walk before we run here. All right, if I have the point x, y, think about the little triangle that's been created. That's always my theta, right? This side is x, this side is y, and this side is r. Yes, like that is nothing new, right? We know this. Okay. So if I said cosine of theta, what would you tell me that equals? X over R. Okay, a little worrisome there. Got quiet real quick. All right, what if I wanted to solve that equation for X? What would I do? Okay, so that means R cosine of theta is equal to X. Okay. Then let's think about sine of theta. In this triangle, what would sine of theta equal? Y over R. And if I solve for Y? Alright, so in those little blanks down below there, if you're given the r theta or the xy, you can convert to the other using these two equations. So I know x is equal to r cosine of theta, and y is equal to r sine of theta. That makes sense, right? Like this is building up stuff you know. Okay, so first example there, you're going to convert from polar to rectangular. 6 comma pi over 6. That makes sense to you that that's a polar point, not a rectangular. Okay, so we are going to use these equations here to turn this polar point into just an xy point. So I know I'm going to have 6 times the cosine of pi over 6, and then 6 times the sine of pi over 6. That's going to give me my x and my y, right? Okay. What is the cosine of pi over 6? Non-calculator.
Oh, pi over 6. Oh, I'm guessing cosine pi over 6.
And then sine of pi over 6 is a half.
Oh yeah, remember the true proof.
Wait, so I'm
Those
an
haven't gone.
exact degree, but I don't need
It hasn't gone well.
I said they haven't gone away,
Oh,
and you said they haven't gone well.
I mean, I agree with that last one. That's not all. They don't really do well for me.
Not for me though.
Okay.
Yeah,
You
no,
can
it's
study.
Okay, give me 3, let's go.
All right, so we end up with a point root 3 over 3, or sorry, 3 root 3 comma 3. What this means, if you plotted 3 root 3 and 3, if you plotted that point, the angle you just traveled through is pi over 6, and the length of your radius there is 6. Okay, like they're the same thing. One is plotted on rectangular, one is plotted on polar. Does that make sense? That is what you're doing. Okay? So, with a lot of the things we do in this unit, guys, you definitely need to use your brain, which I know I'm asking a lot. Think about if your coordinates for everything make sense. You know what should be positive and negative based on the different quadrants you're in. So make sure what you end up with is actually the right size that you should have, okay? So I want you guys to try 2 and 3 for me. Turn those into rectangular coordinates. Change them from polar to rectangular. Give you a minute there. And guys, I just found the schedule for Friday. Even though the assembly is during 5th period, we get to spend a lot of time together on Friday. So class, we have an hour of class first, so you're in here from 10:15 to 11:15. Then you go to the assembly from 11:20 to 12:15. Then you go to lunch from 12:20 to 12:45. And then you're back in here from 12:50 to 1:20.
So really they're just subtracting.
There's no Warhawk time, and your other classes are all like a little bit shorter.
It's still really long. So it's a lot all the time.
First period, here. Why don't I just do this for you?
It's still a full day.
Okay, there you go.
Every class.
Feel free to take a picture, or it's going to be in the video now for everyone.
Oh, really? Oh,
Yeah, we can watch it, put it up here.
That's how I get over it.
Yeah. Yeah.
What I wish, remember like 2 years ago we had other release on that day, the winter break. I would love to have that
A
again.
few years ago you did, yeah.
Did we have it last year?
No, last year was a full day.
Last year, the year before was the house in the middle.
It's not.
Oh, I'm not happy with the run says I'm like, yeah, I'm Or at least I got after like pointing out something about
So we're together for over 3 hours.
Do we have to
What? Because I'm
everybody else is hey, I want to stay and miss the weights class and do math questions.
Yeah, I'm not going to be in here. I'm going to the assembly.
I mean, I wouldn't
Okay.
be doing either.
So, everybody good? All right, are you done with 2 and 3? No? Okay, all right. Sorry, I interrupted your train of thought backwards. That kind of week, guys. Once you have them compare with somebody, talk about it. You're going from a -4. Remember to do the radius first. On the right.
You don't say anything. What did I get wrong?
That's classic.
What did I get wrong?
Okay, guys, look up here. Number 2 is the trickier one. If you have -4 and then negative pi over 4, what quadrant, if you're thinking of just your rectangular quadrants, is this in? 2. Remember, you got to do the -4 first, and then back up pi over 4. So that's actually a second quadrant point. So your answer should be -2 root 2, positive 2 root 2.
Oh, wait, I still got it.
Wait, that's what I got.
Yes.
Wait, so I got wrong. Wait, you got wrong. Wait, no. That's what negative.
Wait, I
Yeah,
got
you put negative one.
Do you get why it's like second?
Yeah.
I say I did -4 times 7 pi over 4. Is that but
Yeah, you got it.
I thought I could get it.
So if you were to graph this, I know I'm not drawing, I mean,
I was explaining.
Well, I guess I'll.
So-
Correctly, I know mine.
-4, you go this way first, and then you go back.
Don't call me Alex. Every Alex is don't call me. Don't.
Yeah? Alright guys, and then your answer for the third one there should have been 5 halves and -5 or 3 over 2.
Yeah.
That one's easy.
Yeah.
Questions, guys?
Yes.
Yes.
So we're learning next class also on the set.
Graphing. But like graphing lines and circles.
No, it's okay. You don't do wrong. I'm stressing on everything in this. Everything I learned, I stress.
Alright.
See, what I do is I tell everyone that I'm stressing for what they should stress.
Okay, guys. The next part here, if we're converting from rectangular to polar, I recommend you always sketch the picture first. So, like, plot the point. You know how to plot points in the rectangular coordinate plane. I promise you know how to plot those points. And then you're just using, thank you, the distance formula to find the length of your radius. And then you're going to have to find the angle. There's 4 little graphs here because you can think about if the point is in the first quadrant, there's R, there's theta, right? If it's in the second quadrant, so we'll do X, Y. There's your R. The theta now has to be bigger, the second quadrant angle. Let's say there's your XY, this length is R, your theta now is all the way around. Fourth quadrant, really big theta. So just to make you recognize, like, okay, I gotta find an angle that actually makes sense with the ordered pair I'm starting with. a lot of times what you're going to want to do is find the reference angle. Do we remember anything about reference angle?
Oh, so how we
Okay, it's always acute. It's from the first quadrant,
From the x-axis.
from the x-axis. A lot of times you're going to find that reference angle and then use that to end up in the second, third, or fourth quadrant. Yes.
And that's I found like how to find it like on like the outline says three couple dummies and it just goes to the book and it says one
All right.
there's some
Actually.
Let's do number 1 together. All right, so 2, -2. Where is 2, -2? Fourth quadrant, it's down here, right? That's 2, that's -2. All right, so find the length of R. Excuse me, thank you. Just distance formula here, it's the square root of x squared plus y squared. We simplify it, what do we get? What'd you say? 2 root 2, yes. Because it's root 8, which is 2 root 2, yes, okay. So the R, that is not hard to find, right? The theta. Okay, we know an x and a y. What could you use to find an angle? Tangent, yes. So, I know tangent of theta equals my y over x. Now guys, the theta you're actually finding is this guy in here. Is that the theta I'm going to want as my answer? No. Yeah, you want like all the way around. So guys, you do not need a calculator yet. I would actually not worry about the signs in your ordered pair, and then at the end, make sure your angle actually makes sense for the quadrant you're in. So I'm going to do it as if it's just 2 over 2. So that's like 1, right? So when does tangent equal 1? Give me the reference angle in the first quadrant. Pi over 4, right? Okay. Is pi over 4 the angle I want? No, I want to start here and go all the way to there. So what is it going to be? 7 pi over 4. So your polar coordinate is 2 root 2, comma, 7 pi over 4.
Why is it 7 pi over 4?
Okay, what do you want it to
Oh,
be?
because it needs to be quadrant 4.
Yes.
Okay, that makes sense. Let's do the rest of them.
All right. Try number 2 for me. Don't do 3 yet. Try 2. Try number 2. Don't do 3 yet.
Every time we find the distance is always positive, right?
Yeah, R is always good. Well, I mean, well, let's think about it. Couldn't I also say this is -2 root 2 and what, 3 pi over 4?
Yeah, so.
Or -2 root 2 -5 pi over 4?
Okay, so.
Or 2 root 2 -pi over 4? I know, now I'm messing with you. So, those are all the same point in the polar graph. You may have very specific directions. Your theta must be between 0 and 2 pi. Or I can do weird things and be like, your theta has to be between -2 pi and 0. Okay? So.
You generally tell us to stay away from complex negative.
So yes, let's say theta must be between. Let's do that, okay? How are we doing on number 2? Don't do 3 yet. I'm going to give you specific instructions on 3. I know you really want to do 3.
Alex is better.
Absolute grace.
He just wanted everyone to know. Someone moved this test really slowly. That's a perfect quiz too.
Oh, so he doesn't need to count, I guess.
What if you wanted to keep? What if you thought about running years like this?
Alex. Alright guys, what did you get for your answer on 2? 2, 4 pi over 3? Yes? Anybody questions?
Let's do number 3.
Okay, number 3. This is one you need a calculator for. And I'm going to have you do it in degree mode. That's why I wanted... What you have to wrap your brain around with this one, it's just easier in degrees first than it is in gradients. So, if I plot my point, I know I'm in the third quadrant, right? Okay? -0.8, clearly drawn to scale here. Lovely. Alright, find your r first. So -0.8 squared plus -2.1 squared, square root of that. Let's go 3 decimal places. What do you want? Yes. 2.246. Are we okay with that? Okay. The r, there's nothing tricky with that at all. The theta, let's think about it a little. So we're still going to use tangent. And guys, again, I would think about reference angle from the first quadrant. So I'm thinking 2.1 over 0.8. What are you going to use on your calculator to find the angle? Yeah, the thing with the -1, the inverse tangent. So key in inverse tangent 2.1 over 0.8. And to 3 decimal places, what do you get?
69.1.
Okay, 69.146 degrees. That is not in the third quadrant. Are you in degrees? Okay, so to get in the third quadrant, guys, I know my reference angle is the 69.146. To find my way into the third quadrant, never, never, never come from the y-axis. Just like when you draw your right angle, it's always from the x-axis. So I know to here is 180 degrees, right? How much farther do I then want to go into the third quadrant? Yeah, 69.146. So what are you going to actually get for the theta we need? So your coordinate for polar is 2.247, 249.146 degrees. So if it were in radians, what would you be adding or subtracting from? Pi. You could use pi, you could use 2 pi if you need to. Okay? You guys need another one of those, or does that make sense? You want one more? Do one more. Okay, so random number 4.
Alright, I'll put it right here.
We'll stay in degrees. Let's make the x negative, sorry. So negative 2.1, 1.7. I gotta do this too. When you're ready, look up here and check. See how you do. Do you agree with me? Do you disagree with me? No, second quadrant, let's see, sorry. It's what I started writing it as, and then I didn't. So how about 141.009?
Not 120.
What are you getting as your theta? Okay, so let's think about it. If I'm at -2, 1.7, I'm somewhere over here, right? So the theta, the 38.119 is right there, which means it's right here, so I need to start from 180 and go backwards how far? Yeah. Always from the x-axis, and then you're using that angle that you found. See? Good, we did another one. Alright guys, questions on that? Do we get it now, or are we stuck on how we're getting the 141.009? Sure. Never go from the y, so never start with like 90 and add or subtract, okay? Always from 180 or 360, 80 pi, 2 pi. Yes? Yes. Do you need another one? Yes, okay.
Probably.
Yeah. Alright, let's do... one more.
Extra practice always helps.
Can we do mine?
Isn't good when I run out of space.
Isn't good when I run out of time.
So you guys don't have extend page on your... Okay.
Yeah, and
In the future, we just keep getting future. The future looks bright. Those are really deep things. For 180 miles. I take back my things.
Check when you're ready. Do you agree with me? Alright guys, you can go to lunch and then we'll finish this after. Okay?
No, wait!
Alright guys, any questions on these with the calculator? Are we understanding now you can only add or subtract from the x-axis?
Yeah.
Okay, that's good. Okay.
Hey.
Well, when I used inverse tangent and found the reference angle, like, you want me to call it reference theta?
Yeah, I call it reference. I just say reference. So I know that's
Honestly, normally I wouldn't write it down.
In Australia,
Alright guys. Okay guys, we did points from rectangular to polar and back. Now we're actually going to transform equations back and forth, okay? So, Over here we've got this little box that says steps. I'm going to change this to stuff we know. What does x equal? What's something you learned today that x is? R cosine theta. What does y equal? What is r gonna equal? So what is this? How about square root of x squared plus y squared?
Yeah, I want this one.
So what would r squared equal? So that's, I should have called that stuff I hope you know, not stuff we know.
I do know it. I just John said
Alright guys, so let's go through the first one together here. We are given r equals 4 sine of theta. You'll get to a point where you will immediately recognize what that is. Guys, you'll know exactly what the graph of that looks like. We are clearly not there yet. So we're going to turn it into a rectangular form because you do know the rectangular equations, I hope. So I see 4 sine of theta. It'd be kind of nice if there was an r in that, right? Like if it was 4r sine of theta, wouldn't that be helpful? So I'm going to multiply both sides of my equation by r. That's going to give me r squared equals 4r sine of theta. Okay, stuff we know. What does r squared equal? X squared plus y squared. Realize the point of what we're doing here is to get rid of the r's and the thetas and end up with x's and y's, okay? And so it's going to equal what on this side? 4y. Okay. Technically, yes, you have converted that to rectangular because there's no longer an r or a theta involved. We're going to do a little more with this. Okay. All right. So, I'm going to do x squared plus y squared minus 4y. Leave a little space equals 0. What do you think I'm going to do?
Complete the square.
Complete the square. You guys are cool at that.
Yes. So that's why you've been doing all those tests.
Yes.
That's why you've been doing it.
Alright, what am I actually adding to both sides, guys?
It's like graphic letters. No, because mine is going up. It's like graphic design. It's just sometimes go up and then
Does that make sense to you? Clearly, I'm not showing you all the steps of completing the square because we've got a lot of completing the square.
So how do you figure out 4 with the number square root?
So you take this coefficient,
Yeah.
divide it by 2,
Yeah.
Square it?
Okay, so it is just
4 divided by 2 squared. Yes. Okay, so that is where I'd like you to stop with turning it into rectangular, and then conic sections. Do you know what that's an equation of? Circle. I said conic sections, and I thought
Everyone's got
so.
it. I like bro. I got 88.
I mean, I got extra, I got you.
Yeah, so stupid.
I mean,
I wanted to do
Yes. So, are you okay with multiplying by r? Give me r squared over here. I know r squared is 2 squared plus squared. So I'm just replacing that.
Good at math.
And then this time, if you ignore the 4, you know, r sine of theta,
That would be
so this is why. So plugging it in and moving it over. Okay, try the next one, guys.
Please come back over again.
Yes, welcome to math. That's how it works.
Wait, Alex, what's that?
Yes, welcome to Big Dog. I'm going to kill you.
That's a little extreme, but
Well, wait a minute. Welcome to Big Dog. I'm going to kill you.
okay, stop.
Step up. Good example.
Really?
Hey, John, that's very offensive.
And guys, on this one, you can stop once you have eliminated the r and the theta. Okay?
Let's do the next one.
Oh
I'm
no.
square root in your
This doesn't look very fun to do, actually.
What?
This
Oh,
is
sure, sorry.
not very fun to do.
The whole point is to get rid of the sines and cosines and r's and
Oh,
thetas.
the second. Oh, that's
Oh, okay. I thought you were still on the r equals one. This was one of the Alright guys, let's look at the next one. Alright, r equals sine theta plus 1. I'm going to start the same way, multiplying by an r. Do you see why I'm multiplying by the r? I want that r sine of theta, okay? So I get r squared equals r sine of theta plus r. Okay, what's r squared? Alright. What's r sine of theta?
Why?
And what is r? Okay, that's not going to be a circle or anything fun for us, is it?
not really.
So, you've eliminated r and theta, so there you go. You have converted it to rectangular, you can stop there.
Okay, wow. That was
One thing with these, because I know it's a question every year of like, how do I know when I'm done? So, if all I say is convert to rectangular, once you've eliminated r and theta, you're done. If I say, like, identify the conic section, if it is 1, you have to keep going. Or realize these could be multiple choice questions. And so the answer may be some variation of this. So you need to just be okay with simplifying or manipulating it to make it look like multiple choice. Does that make sense?
Yeah.
Okay. All right, questions on the first two where we turned it into rectangular. Okay, so now let's take rectangular and turn it into polar. We'll do the first one together. So I've got 4xy equals 9. So I'm going to leave the 4 alone. What could I replace x with?
R cosine.
R cosine theta. What could I replace y with? Equals 9. So far so good, right?
Yeah.
Okay. If I multiplied this side out, I'd get 4r squared sine cosine. Or cosine sine, it really doesn't matter. Okay, again, technically you have now converted it to polar.
That sounds fun.
Alright, so you need to recognize that I could use a formula on this one. You guys remember your formula is like double angle, half angle, Pythagorean, all that good stuff? Alright, so I'm going to leave the 2r squared out here. Just look at what I write. And then I'm going to put part of it in here. Do you guys agree that that's the exact same value, right? Like I haven't actually changed anything. I turned a 4 into a 2 times 2.
Oh no.
This is rocket science.
Alright, so
I knew they were coming back.
It's like this 90s
do you guys see it? 2 sine cosine?
Yeah, that looks great.
That's double angle formula. I know.
Every single
We don't put it in our equals though.
Sometimes not necessarily.
Can't divide by sign. That was a victory.
Wait,
Yeah.
Those are my for house and that was a call for help.
Yes, and I've been telling you that all
So
year.
does, you can't divide by sign, right?
I'm not recommending you divide by sign.
Okay.
Well, you can, you just don't want to eliminate any of the variables. So like if you solved for r, you'd have 3 over the square root of 2 sine of 2 theta, plus or minus in front of that. Again, just recognize like multiple choice things, you're going to have to recognize those formulas.
It's just that.
Okay? Alright, so you guys try the next one. Y squared equals 2x. You guys try.
Okay, let's do it. Solve for why?
Focus.
How are we doing, guys?
I'm getting there. I'm trying to remember a couple more.
Are you just kind of going in circles at this point? You're like, well, I could substitute that, and I could substitute. Okay, so let's look at it. So first, y squared, that's going to be r sine of theta, that entire thing squared. Okay? And then this is going to be 2r cosine theta. We okay with that? Alright. So I've got r squared sine squared theta equals 2r cosine theta. Again, you've eliminated the x and the y. You've turned it into polar. So, like, I would accept that as an answer. You could also substitute for sine squared if you just are like, you know what, I only want cosines in my answer. What could you replace sine squared with?
I couldn't remember that though. I can't remember it.
That's fine. You could distribute. You could bring it over. I don't care. Like, these are all just,
Any variation.
yes.
Another
I
one.
write the questions in a way that you'll be, like, you'll know where to stop. Okay? You can factor an R out of that. You can, like, you'll be fine. Okay, so does that make sense? Pretty much anything from here on down I would take as an answer on this. Okay. That is the end of your notes. So, the next page you'll see says practice, and then the page after that says homework 5.1. Yes? Everybody see it in your packet? Alright. I would like you to start on the practice now. I know we only have about 15 minutes left. Let's start working on that, and then the homework for sure will be due next time. But I want you to do the practice right now. I'm probably checking the practice and the homework since they're both just going to have it.
It's not really that long.
It is not that long.